Hello, this video is going to be on the paper that I researched. It's called Forensics Challenges in Mobile Cloud Computing. Um, so, when it comes to mobile cloud computing, it has been on the rise. Not just mobile cloud computing, but cloud computing as a general topic. Many people are now using services like AWS and Azure for their service, for their needs. No longer did you need to have a server rack or have any of these uh, items and maintenance fees all attached to your needs. Now it's all available online, and you can just request it, allocate the pieces you need, and have those services available to you. With mobile cloud computing, it's the same thing. It's being able to have your mobile services on the cloud. Now, because of the rise of mobile cloud computing, there are many things that are now, or many attacks that are now being targeted to these specific individuals. People are taking advantage of authentication processes, finding out what ways to break into these cloud services. And when you actually opt into these cloud services, you no longer have the ability to protect the physical machine. So, for example, if you use AWS, if there's a physical intrusion at one of their databases, and your server, the one you're actually paying for, happens to be there, you would be affected as a customer. You're basically entrusting another company with your data and hoping that it stays secure, encrypted, and only you can see it, which is a gold mine for cyber attackers. They would love to get in there, take any information they can see, and there's a possibility that you might not even know if there's a breach. Now, when it comes to cyber attacks, there's specific ones that people normally perform, especially for mobile devices. One of the most common ones are a DOS or DDoS attack, which is a denial of service attack. Basically, it's just a repeat attack until your servers are down or your whatever application you're trying to use is no longer functional. It is a very, very common attack because it's probably one of the easiest ones to do. You just keep sending packets until you flood the server to the point where it just crashes. This happened around with PlayStation a while back, a couple of years ago, where their servers were flooded for days and people couldn't use their systems out of the box. So it's a very common attack. There's also application-based attacks when someone uses a keylogger of some sort and takes that information and sees you typing in your information in your mobile device, and that information gets compromised in that sense. So there's also web-based attacks that can definitely affect you as a user online, especially in the cloud services where you fall trap to things like authentication or saying, hey, you need to re-enter your password. You think it's the authentic website and it's not. There's network-based attacks, which are attacks directly to your network. Things like man-in-the-middle attacks, brute force attacks, all are network-based. They can definitely hurt a system, especially at the cellular level as well. And then there's also the physical-based attacks, which are attacks to the physical hardware. If someone breaks in, destroys the hard drive, destroys the server room, there's a hurricane and the data farm gets destroyed, things of that nature. Natural disasters are normally the cause of physical attacks. So when it comes to mobile cloud computing investigations, so let's dive deep into that. Some of the investigation challenges that we actually find is data identification, time mismatch, multi-tenancy, owner of data, live forensics, privacy, smartphone operating systems, multiple clouds and multiple cloud service providers. These are some of the challenges we encounter when trying to perform digital forensics on these types of mobile devices. Data identification is data migrating makes tracking in real time easier. So definitely you can, because of data migration, it's becoming easier and easier to track data in real time. No, actually, I'm sorry, I take that back. It's becoming harder to track real-time data because of this. A lot of places require legal documentation, permission to be able to access certain data for identification. For example, iCloud. You need certain permissions to be able to identify a device if you're not the owner of it, especially. It's even more difficult when you're trying to find multiple data centers, and that's one of the toughest parts. Time mismatch. You have sync time logs from different data centers and possibly different countries. So one of the biggest issues is trying to find out exactly when an incident happened. And with digital forensics, timing is crucial, especially the system time. And sometimes the system time might not be synchronized with real time. This can be a major, major problem when trying to determine an exact time, a moment that something happened or an incident happened. You have owner of data. Investigation restrictions due to provider agreements and resources can be possibly assigned to another user. So one of the big problems that you have with cloud services and mobile cloud computing is that who's the owner? If the data is sitting on the AWS server, isn't AWS technically the owner of that data because you're utilizing their services? So you get into a tricky, weird situation when, especially when you're doing provider agreements. If you're using a provider, in most cases, usually they are the owners of the data because it's on their devices. But in reality, you're using the data. It's your data, and that's, again, like I said, that's where it gets really tricky and it becomes hard to identify. Live forensics. No access to cloud networks. A strong relationship needed with provider to gain access to network. So with live forensics, it's very, very hard to do forensics live. Also, you need to be able to have, like it says, a good relationship with the provider to gain access to a network and to be able to perform these types of things. And in most cases, these networks aren't comfortable doing that. We have privacy. Provider signs contract with users to ensure confidence, one of the biggest challenges for digital investigators. So privacy is, for everyone, is the most important thing that someone can have. But when you're trying to be a digital investigator and trying to find out something or trying to determine the cause of something, it's very, very hard when people have signed contracts for confidentiality because they can't share that information with you. A perfect example was in the case with Apple. If a phone is locked and you want access because the person is most likely deceased or something of that nature, Apple can't share that information, even if they knew it, because it would be violating their privacy policy. So a lot of these companies have in place these privacy policies because every person that uses a service wants to make sure their information isn't shared, isn't given away, isn't improperly used, and being used for the right reasons, usually within the scope of the company itself. So again, like I said, one of the biggest challenges they have is trying to break past that and get past that legal veil. Smartphone operating systems. So this is the biggest one. Back in the day, there weren't many operating systems, if any, for smartphones. So now we have a load of them. We have iOS, we have Android, we have Google OS, we have Windows Phone. All these proprietary software operating systems that need to be frequently updated, and cause us to have to find new ways to do digital forensics on these mobile devices. What might have worked in version 1 of iOS might not work in version 2, 3, 4, 5, 6, 7, or 8. And by the time we reach version 8, whatever tools you were using for digital forensics in version 4 are most likely obsolete or have been fixed. So dealing with those versioning of software and proprietary is one of the key things that make it harder and harder to get the data you need to do digital forensics on mobile devices and altogether. So multiple providers. This is a huge one because of the fact that there's so many providers in the cloud, and geographically and technically there's just constraints all over the place. It becomes very difficult sometimes, especially if you're using multiple providers, because then we have to bounce back and forth to find out certain information, to find out certain things, and try to be able to work around just to get into the device and find out the information that we're looking for. So conclusion, most of these challenges are due to virtualization and the distributed characteristics of mobile cloud computing. Absolutely. So when it comes to mobile cloud computing, there's just so much areas for improvement. It's not something that's been heavily researched because cloud computing is still a new thing. We're in an era where people are giving up privacy per se and saying, hey, you know what? I trust these large companies with my data because they're ensuring me encryption, they're ensuring me my information won't be shared. They're authentic and they follow the CIA triad very, very strongly. So it's one of the biggest things that are happening now, and definitely see it growing over the years.